Okay, so today we are going to continue our series on number theory, and today we're going to be looking at converting fractions, decimal, and percentages. So we're going to look at how we could convert each one of these into each other. Unfortunately for this video, you must have already have prerequisite understanding of fractions, a decimal, or what is a fraction, what is a decimal, what is a percentage. I personally did not look at it. However, if I have to, I will, if you need to have that basic understanding before we go on to this video. Prior to this, of course, we would have already looked at number theory in terms of types of numbers. We already looked at examples of how to solve those numbers, and we also look at the inequality symbols in the previous one to this one. Today, we are going to look at the following objectives. So first of all, we need to be able to convert a fraction into a percentage or decimal when given a fraction. So if I give you one fraction and I wanted to convert it into percentage or decimal, you have to be able to do that. Likewise, if I give you a decimal, you have to be able to convert that decimal into either a fraction or a percentage. The order doesn't matter. I don't like to teach in any given sequence, but whichever one I have, you have to be able to come up with the other one. And last but not least, if you have a percentage, if you're given a percentage, you have to be able to convert that percentage into either a fraction or a decimal. Good? So, why should we know that? Or what's the primary reason as to why we should understand conversion? I mean, we do conversions when we do number theory, we also do conversions when we do measurement. But why do we convert? Okay, let me tell you, or let me open your eyes. Firstly, we convert so that we could better understand the value or worth of a number. I don't know about you, but for me, I know sometimes if you give me a fraction, as much as I see myself being very good at math, sometimes when you give me a fraction, I still have problems to date understanding. So for example, if you throw five fractions at me, for example, sometimes I still have problems identifying, no shame in that, which one is the bigger one from which one is the smaller one. So one of the things I do, I am very good with percentage. I understand percentages very nice, and I even have a better chance with decimal. So if I have a fraction, for example, I sometimes convert it into a percentage personally in my head or in my mind, or quickly. I just do that quick thing there. And then I sometimes, that to me, that gives me a better understanding of the worth of a fraction. So sometimes they give me an 8. And I know a lot of students like that too. A lot of students struggle. I mean, I'm not badly off now, but I'm just saying, generally, that was one of my weaknesses growing up. I give a child a half and I give a child an 8. And believe me, a lot of people still believe that an 8 is greater than a half. And when I say an 8, I mean 1 over 8. Some people think that 1 over 8 is more than a half. So if I have to use an inequality sign here, for example, some people believe this is true. And again, I don't blame them because it comes down to understanding fractions. Good? But when you see it written in a different form, if you see it written in a different form, some persons may not, I ain't saying will, but some persons may not have the same problem. For example, the same 8 and the same half. If you go to write the 8 as a fraction, as a percentage, which is my strength, you'll get approximately 13%. And a half will be 50%. Look at that big difference there. If you see this, like this, there is no way, unless you're real backwards, no disrespect, but there is no way you would have something like this. Or unless you're confusing your signs, if you don't know your signs. Good? Because this, to me, gives a clearer picture than maybe this. Good? Well, not clearer, but it comes down to your strength. Some persons, I know, they're very good with fractions. They could see fractions and they know the what. Some persons are not. As a result, one of the things you need to know conversion is so that you could help your own self. So when you know conversion, one problem that you're solving automatically, as a matter of fact, let me stick that pin right there. Moving on, I'll bring it back, don't worry. To easily perform tasks of arranging numbers. So yes, and that's what I was just saying. If you understand how to convert, and I give you 5 fractions, for example, if you cannot see the fractions, you could convert it into something that you could see easily. So like for me, the 8 and a half are converted into percentage. You see 13%, well, you will see 12.5. But you see 13% and now you see 50%. Come on, you can disarrange those numbers. You could see the sequence, you could see the what, you could see the value, but sometimes you may not easily see that as a fraction. And last but not least, and I like this one the most, is of course to solve problems involving these concepts. Yes, sometimes you have to solve a mathematical problem in which a fraction is taken from a whole, and you have to have an idea sometimes of what that fraction is. So for example, there's this common marble question that sometimes students are asked. You know, Tom has 12 marbles, he give Jimmy 1/5, and he give Tommy 1/8. How many marbles he have remaining? And sometimes we cannot see the 1/5 and we cannot see the 1/8. So teachers would have to encourage students, okay, convert the fraction or convert the number of marbles into whole numbers. And then we could easily see how much is a fifth that whoever got and how much is a eighth or whatever number of fraction I said that other person get. And this is the whole reasoning behind conversion. And what I was about to say earlier too is that once you know to convert, you should never ever have a problem with arranging numbers, whether it's in ascending order or in descending order. Even though the teacher may not tell you convert and then arrange, but you need to know that is a math knowledge that you have to use at your disposal. So I give you 40 numbers to put in chronological order, whether ascending or descending, and they're mixed. You have decimals, you have fractions, you have percentage, all in the mix. If you want to have a common picture, then that is where conversion comes to play. Good? So let's look at the concept, and this should bring us to the ending of today's video. So today I'm going to just do this example. In the next video, I'm going to give you some more so that you will try on your own, and then after we're going to build it from there. So how do we go about doing this? So we have one example here, well 3. We have a fraction and we want to convert this fraction to fifth into a percentage and then also into a decimal. Here now we have a percentage, 30%, and we want to convert that percentage into a fraction and a decimal. And then we have a decimal and we want to convert that into a percentage or a fraction. So how do we go about doing that? So starting from the top, if you have a fraction, the fraction is the best thing to start with. Because with a fraction, you could by default get a percentage and you could also get a decimal. How do I get a percentage from a fraction? Easy. I just multiply this by 100. So if you multiply this fraction by 100, just like that, you get your percentage. And according to my calculator, when I do this, I will get 40%. And that is how we get our percentage. So remember the rule, I'm not stating no rules and I'm not going to write it up. But if I have a fraction, to convert that fraction into a percentage, you just multiply that fraction by 100. Good? And how do I get a decimal from a fraction? Well, of course, you could use your percentage if it's easier from this vantage point. But for me, again, it's easier to work it from the fraction. I just divide the denominator by the numerator using a calculator. So that is 2 divided by 5. And when I do that, according to my calculator, I will get 0.4. 0.4. And that does it. That is how I get my decimal and my percentage. Easy does it with a fraction. What if I start with a percentage now? Okay, so this is where it might get tricky, but it's very straightforward for me still. So if I have a percentage now, my approach would be to go to a fraction, because I know that a percentage is any number over 100. And any number over 100, by default, you created a fraction. So I will put this 30 here over 100. As a matter of fact, let me write it in the other place. So that will be 30 divided by 100. That's my fraction. And of course, after you make your fraction, you'll see if you could break down. And in this case, we could. We could use 10. So 10 could go into 30 3 times, and 10 could go into 100 10 times. So that will give us 3 over 10. And that's the lowest this fraction here could go. Yes, 3 over 10. Very well. So we have our fraction. And like we just did above, how do we get a decimal from our fraction? We divide our fraction. If I divide 3 divided by 10 with a calculator, or you could do your long division, but here I'm just taking a shortcut, you will end up with 0.3. And from the percentage, we got our fraction and we got our decimal. Hope I'm not going too fast, but if I am again, you can always pause the video and go through that process again. And in the next video, remember, we will do some practice. So you could always go to that video and see how we strengthen or consolidate these rules. And then we have a decimal. And for a decimal, I always like to start it like this. We could picture this decimal as this number over 1. But mind you, this doesn't make it a fraction yet. Yes, it makes it a fraction, but a fraction that is not necessarily any different from the decimal. But the reason why I want us to put that 1 there is to understand that any whole number for itself, or not whole number, any number for itself is the same as a fraction when put over 1. But to this one, we'll be adding zeros. So how do I add 0 to this? Simple. We move the point. So I have 0.12. And my aim here is to make this 0.12 into a whole number. And for that to be a reality, then the point has to come over here. But how do my point end up over here? By moving it 1 place, 2 places to the right. And because of that, I also move 2 zeros, or rather I add 2 zeros. So that will actually leave me with 12 over 100. Yes, that is what I have here. Just jumping the gun a little here. I know that any number over 100 is a representation of a percentage. So 12 over 100 is actually saying the same as 12%. So let me just write my percentage here one time. So I get a free percentage here without having to do any calculation or multiplication. Of course, just to skip the gun in advance, if this fraction did not end up over 100, remember, to make it into a percentage, we just have to multiply by 100. But notice, even if we multiply this by 100, the 100 will cancel this 100, and of course, leaving you with 12. So it still goes to say that it's true what we did, right? Just take note of that. So yes, I move 2 places to the right, and that may give me 12 as a whole number over 100, which is the same thing as 12%. But now this fraction here could break down. And you could use different numbers to break it down as you wish. So what numbers would I use? Let's start with 2. Let's start with 2. 2 might be the biggest number. So 2 divided by 12, I know would give me, hold on, let me write. 2 could go into 12 6 times. And 2 could go into 100 50 times. And sad to say we could go again, because I know 2 could go into 50. So then 2 again could go into 6 3 times, and 2 could go into 50 25 times. So which number should I started with, Brian? I should have started with 4. Right, 4. I could have used 4. So 4 could go into 12 3 times, and 4 could go into 125 times. But I didn't see it that way, sorry. But it's okay, I still ended up there. Yes, and that should be our final answer, because 3 over 25 cannot go any lower than that. And yes, people, that is how we basically do conversions. I trust that this video is helpful. In the next video on Monday, God's willing, you could just log in to see that we do some more practice. Maybe I'll come up with 5 random ones. I'll give you a chance to do it first as always, and then I'll just step into solving. So again, until Monday, again, you enjoy the rest of your day, your weekend, and be sure to like, share, and subscribe, share it with your friends, share it with persons that are interested or just love maths, and then we'll take it from there. Until then, au revoir.